we have the filter set in position 4. So the signal is blocked off. And we're going to do an auto zero.
So you blocked off the beam to do an auto zero, so that we see the empty instrument and we see the dark current on the photomultiplier, so we have an auto zero, we find an auto zero base. Very good.
Now
We're turning now the high voltage up to get us the signal. And it was before okay, and when you had the high voltage, when you had the shutter closed, you had just a minimal signal on the photometer, which was basically the dark level, and now you have turned up the high voltage to give us a signal level, right?
Right. Lock it in there.
Now, how many volts do we have on the photomultiplier? Can you show me this, please? Okay, you have 778 volts on the photomultiplier. Very good. Thank you. That gives us the voltage we have. And we would in this case obviously look first where we have the highest signal coming through on a scan, I presume, right? So we don't run off scale, right?
That was the 160.
So the 160 was the highest one, and you choose the 160 because this is the strongest line in this particular deuterium lamp, right? Okay. Okay.
And we'll do a reference scan. And go from
go from 100 nanometers or 115 nanometers. Okay. You will go up to 200. Very good. So now we have the vacuum range of this particular spectral area, and you had found your highest point at 160, and you had gone to 160 so that you don't run off scale, I presume, right?
Stability, we're at 1%.
Okay.
Okay. Then do a reference scan.
Fine.
Right here.
So you had set the stability, you set the reference scan, and then you initiate it. Okay, and now you start to scan basically, and this means now the monochrometer will be actuated, right? And we will see most likely the wavelengths going down to 115 now first, finding its starting point. It goes slightly below 115, it comes up then to 115 to take the backlash up, and now it will scan in the pre-selected intervals, in this case 20 nanometers. And we choose this particular interval to basically show that we can scan in intervals, but smaller intervals would take too much time. And we see now the scan advancing here from 115, it's up to 125, and did I say 20 or is it 2 nanometers? There must be 2 nanometers. Sorry, I looked at the extreme scale, but it is advancing not in 20 nanometers but in 2 nanometers. Okay. Now this is a very interesting display now, because on this side we see basically the noise of the baseline or the baseline behavior within actually 1% or less than 1% of noise. As we see this scale here, all these ripples are within the 1% range on the baseline. Now the signal now comes higher, goes higher up, so there is something there, there is some signal there, which is 1.4 or 1.2%. And this is all baseline behavior now. And now we have something going towards the 160, where this big peak in the deuterium source will occur, and we are now riding over that particular big peak. And as you saw, we had gone up to 4 on the scale, coming down now from that big peak. And while all this is happening, we are obviously storing all this data for treating then a sample with the proper baseline reference. Now we see these slight steps in here. These are basically steps now of the 2 nanometers, which we had indicated before is the stepping speed of the scan, right? And we see always the step advance is indicated on that particular stepper controller.
For your reference scan, you bring the voltage here.
Right.
So you see.
Okay, very good.
And you do your reflectance of the transmission scan. It reads actual reflectance here.
Right.
So there's no calculator.
Yes. This is a selectable range then. In other words, we can select the reflectivity or transmissivity by putting a transmission scale on here, which is 0 to 100, which would be then 100% transmission amplitude. This will be showing on that particular scale. I think you have this in the software, so you can select the.
You can enter a memo here.
So that means we can basically say what we scanned and memorize it.
Try that again.
Okay.
Now save it. Click on this one.
Very good.
Now you have to name your scan.
Fine. So very good. So we have a good file for this. And now we save it. Very good.
Now at this point you could go on, you have your samples ready.
Right.
And do reflectors or transmitters right here.
Okay. Oh, these are the functions I mentioned before. We can now run the reference, we can run the transmission, the reflectance, optical density, or a time scan, which would give us the dynamics of an event. That means if we would have a gas which is photochemically affected, we would probably see its reaction in a sense. Very good, very good, very good. Well, that's very good. I think this gives us a very good idea what this instrument can do. To run samples would be too time consuming, but the instruction manual for this unit and also the literature for this unit contains reference spectra and sample spectra for any interested party to examine.